Is this visible to you? The circuit diagram?
Yes, sir.
Okay. In previous class already I mentioned that whenever if, we are making particularly ASIC architecture or hardware architecture or ASIC, we told that how to configure the entire system. And these signals which are here given this now I shadowed the pink color, actually these are coming from the control unit. That already earlier I have mentioned the application of the control unit. And whenever you are getting these things, this is an internal variable. That's for P select key, which will take the value of X and Y. Initially, first value will come from this one, and from next consecutive, the value will come from here or from here. Okay. After minus, the updatation will help this. Okay. Now, if P not equal to Q, that means if I am telling this condition is true, if this this condition is true, P not equal to Q. If this condition true, I think this is not the condition. If this condition is true, then the signal will state change will happen. That's why it is go to the control unit and corresponding the FSM will change the state, and either this or this will be activated again based on this condition. I told it earlier. Again, you if you find notice it when this comparison come this for P, and you will get the signals red signal is come from PQ and this signal is come from, so P R key both are, so it is a comparator circuit. It's also comparator. Sometimes same comparator circuit can be reused, though I have given separately here for the same ALU, because this is the entire task of the the ALU part. And after comparison, then this subtraction either P equal to that is Q equal to Q minus P, that is Q minus P, or you will get P equal to P minus Q. Any one of these subtraction will take place, and accordingly the value will change. That we have discussed in the last classes, and finally we have shown that the controller for this architecture how we have developed. So this is the actually our FSMA, which will be the CDFG we mentioned control data flow diagram, and here you have seen that the which signals are required for the purpose of the designing the control unit and which is required for the output come. Did you try the last task I have given? So how to create the data path? Create a register for any declared variable. That is number of register here I have to consider for the declared variable. Functional unit, functional for each arithmetic operation. That's why I have done it all separately. I told that single ALU can be iteratively used, but for the purpose of the design, you make it separately. Connect the ports with the register and functional unit. I have connected the register and the functional unit. All I have given connected. Based on read and write, use multiplexers or multiple sources, because these are two value needed update, one for input and one for inter. So this will be the our required multiplexer. Create unique identifier for each data path component, control input and output. These are control input and output for this purpose. So you have to follow first to solve the data path. Again, here I have shown that this is the FSM we are creating for the data path, which will control actually. So we can say when this will come, when this reach will happen. So suppose the controller sequence some bits, and that bit will be enable this one, and this bit will be enable this one. Sorry, Y select and this one. Okay. And after that also, when this situation X and Y ID is selected for this purpose, and again you will find that this condition I think this and this condition will check, and after this check, this is signal whenever they either they will generate this or this, according to it will work. So that's why you can creating the first controllers FSM, that is the very important part you have to first create. After that, you now check that you can briefly you can read like in this way. Initially you can do in this way, and then you can explain like in this way. So FSM, finite state machine construction, is the very important part for this manipulation. Probably I will give the deadline this week, so you have to solve it. So now you see this is the abstract model for the controller logic, and this Our main target there, you have to run these and two parallel for the assignment given. So that is up to we have made one single instruction processors, and after the concept of the SIP, we make the GCD computation for that purpose. So in case of single instruction, here we have used multiple now custom single purpose processors. As an example I have given, you have to make a processor for this one. So you can make this purpose, from this you can design this also circuit. I think in our digital logic, you have to remember digital logic design, we have shown how we have to do the state diagram for the hardware circuit. Is it possible or not? I think we have studied from these to this state diagram, from this state diagram the kernel from the function, and from the function is circuit diagram. Finally you can analyze this also. We did or not in our DLD third semester? That means directly from use case to hardware circuit. I think we have made this one.
Yes, sir.
Forgot probably all of you. Sequential circuit design, in these classes we have discussed this thing. So that was previously we have made. Now today we are entering our next chapter, that we can say FPGA, field programmable gate array. I would like to thank Dr. Konstantinos Status for providing this slide. Actually, this slide is nicely prepared by Konstantinos. Now, before that, I would like to start one whiteboard. Is it visible? Whiteboard?
Yes, sir.
Okay.
Yes, sir.
Now, here you notice one very important thing, that already we have seen three category of the circuit. Three category. One is probably we have seen GPP, we have seen ASIP, we have seen ASIP. You have seen or not all these criteria? It is completely hardwired. It is programmable plus hardware concept, and it is flexible, fully programmable, so high flexible. But sometimes we would like to get another view here in this domain. That means we are entering some where it is programmable, but once programmable it is completely hardware, so that speed will be our desired speed and performance will be very high. That means you are approaching completely towards the hardware but not hardware. Here what happened, that here it is software plus hardware, both are parallel, but hardware cannot be configured. Now we are entering in a zone where hardware can be configured, but once configured, it will behave like a ASIC. Are you getting my point or not? So you are towards going to the direction little bit. It is not completely ASIC, because ASIC is very hardware and very faster. But once ASIC is built up, this is fixed. This is fixed criteria. Now our motivation that it should behave like ASIC, but it should be configurable. Configurable, or we can say it is be programmable. That means by programming, I will modify the hardware and my hardware will act as per my goal. Are you getting my point or not? So you are little bit moving toward the ASIC, but you are not still ASIC. Some programmability is still present, but once the program is finished, it will work like a ASIC. But this ASIC can be reconfigured in a single same circuit. Here it is not possible. One, it is fabricated, it is not possible. But here you can reconfigure as you require, or as you when and it will be required. So that's why this domain, which is not completely ASIC, not completely ASIC, it is coming on programmable logic devices. Programmable logic devices, I can say PLDs. Is it clear the concept of PLDs? Is it concept of clear? PLDs?
Yes, sir.
Programmable logic device. It is completely collections of a set of OR and AND gate. By providing the proper configuration of the AND OR gate, whatever the input I provided, I will get different output. That means if you provide here AND gate or sorry OR gate, here OR gate different function, we combine this function, this with this function, and finally you get OR gate output here. So that means I am telling there you are just creating a AND OR network. You are creating a AND OR network. Is my text is visible to you, or I have to make the font little bit thinner like in this way? Which one
Sir,
is visible good?
it's visible, sir. So the
I,
first one
this
is
one
not
is
visible.
good. It isn't good.
Yes, sir.
Okay. Actually, so many students use spectacles now. That's why writing thin. But in CSC 302, they prefer this font. Oh, that's why I asked. Which one will be good for you? No issue. So there's the end network. You can configure that end network and result function can be received. So there is the concept of the PLDs. Now issue is there in PLD design. We found that one of the prominent PLD which is highly important, that is FPGAs. So we can say field we can write field programmable gate arrays. I'm writing arrays, that's why I've given FPGAs. Okay, so FPGAs are field programmable gate arrays. We have to think. Now let's see the concept how is arises. Generally array of gates will be there and I have to select. Suppose I am doing 2 input AND gate. I would like to implement a function AND gate. This is the output. Sorry. So this is the behavior of the AND gate. Okay. Now, if in our previous again DLD, say DLD class will come, implement this logic, implement this logic with multiplexer. How will implement it? How do you implement it?
Sir,
Any
implement
idea?
it with the multiplexer, sir.
Yeah, using multiplexer.
Yes, sir. Standard circuit.
Yeah.
It's a standard circuit. Like
What is the size of the multiplexer that time?
So 2 by 1 mux.
2 by 1.
2:1.
Yes.
2:1 marks. Okay. So I consider two value. What will be the input here?
So the values, sir, like the inputs 1 and 0.
So the and we can do
I think from any one of these I will consider the input.
Yes.
Any one of these I will consider the input. Am I correct or wrong? So if a twist one marks, I can say this is my input to the marks configuration bit, either 0 or 1. Okay,
Yes, sir.
either 0 or 1.
Yes, sir.
Now here the function I found that in both cases 0, so it will be 0. In this case it will be C. Am I correct? Sorry, B. If I consider output is AB, so here output is 1 when input is B. So I think there is 0 and this will be B. Then you'll get the corresponding output here. Am I correct or wrong? Tell me, am I correct or wrong?
So you're correct, sir.
yes, sir.
So what happened there? If your input is 0, so always 0 will come. So in this case, it's always 0. When your input is 1, you are not coming in this domain. If the B value is 0, you will get 0. If B value 1, you will get 1. That's why it is B. So like in this way, we are implementing this function actually.
Yes, sir.
Okay. Now another important has that criteria that if I think like in this way, same AND gate, AB 0 0 0 1 1 0 1 1. output is 0 0 1. Now suppose that I am doing another multiplexer where I am feeding this four output here, and I am taking the input as my bit, configuration bit. That is, I am telling into 4:1. The
Yes.
output will be same or not?
Yes,
If it
sir.
is 0 0, it will have activated. If it is 0 1, this will be activated. If you 1 0, this will be activated. If it's 1 1, this will be activated. In previous cases, if you see the previous slide, I have to check the programmability feature input based on this one. Now my criteria there, among these two, I am taking all as my configuration of the marks. Okay, so what should I do in this case? I am doing here that input whatever is there, the output whatever is my record, I am storing the output in a array. I am storing the output in a array directly. That means there is no thinking of what will come or what should do. No, frankly, simply, I am just considering all the output in a storing in a location. That is my criteria, and just configuring the bit, I can do these things. So that is the one way with the help of the marks we can do.
Yes, sir.
And another way, marks. Okay. You just see the how the concept is come. Again, we can do. I have a 2-bit inputs lines are there, A and B, and I have some decoder. Decoder. Okay. So decoder output will be 4. Based on the input for this one, any one will be activated. Am I clear? And I
Yes.
am storing a corresponding output. So if it is 0 0, if it is 0 0, then this will be activated. If it's 0 1, this will be activated. If it's 1 0, this will be activated, stored. If it is 1 1, it will be stored, like in this way. And same thing, a same this output I can receive for the read location. Just I am reading this location will help me for the correction, because based on this I will read this location, based on this I will read the, because the output of the decoder stored in the location. Same concept, if now we can implement, so how we can do it? Now what happened that I am now implement that programmable concept. This is our programmable logic. We would like to implement it. So how we can implement? Just little bit get idea about this. I am coming to the slides again. Here the concept of first FPGA that we will implement, the implementation of simple CPU, that is hardware is the Xilinx Spartan 3 starter kit. It is available in our laboratory. This is very unfortunate that in this pandemic you can't do the laboratory, but when you come in the laboratory, I will show this board is available in the laboratory for your practice, and software is Xilinx ISE used for this one. So this is the actually hardware board where you are using, and whatever chip I am telling, that is the FPGA. It is present here. You can use with this port also, different ports are there, you can configure it, and also these buttons are there. So what happened that, just 1 minute. Now in this cases you find the Xilinx Spartan FPGA, that what is inside it. Our target is that what is present there. I have to find out this part. Are you getting my point? My target is that I have to find out this part. What is present inside this chip, that I have to program. Now what my discussion will come, actually I am discussing this part. Now what I have seen in earlier cases, the FPGA, that field programmable gate array, is an integrated circuit that can be configured. See, it is an integrated circuit, so it is a IC. So the concept of the IC is still there. Is it clear? It is a completely IC. Now after that part, you will say that is configured. So I can say it is ASIC, but IC plus configuration. IC plus configuration by the user to emulate any digital circuit. So you can do multiple digital circuits or more than one or any digital circuit as long as there is enough resources. Now that is the another important issue. What are those resources here we are mentioning? An FPGA can be seen as an array of configurable logic balls. So FPGA you will find as an array of CLBs connected through a switch box. So it is nothing but CLB block, we can say CB plus SB. So CLB and SB are the main fundamental blocks for the CLB will configure to implement the main digital logic function and SB to route or propagate among the different CLBs. So these are the our target. Now if you look the whatever FPGA I have told inside, actually this is the thing happen in different board. The architecture may differ, but actually this is the fundamental architecture. Someone have more than 2 or 3 or 4 configurable. Here I have used 4 configurable block and corresponding here you find 5 SBs are there. So actually from here to here or here to here it will go. This routing will be configured by the switching box, like in this how it can go. So you can configure the CLBs for actually the logic function and that will be driven to the next, because the input for the CLB and output the CLB also depend on the input of the CLB. So SB also plays a very important role synthesizing a particular function. So SB, but what are the main tasks of SB? Actually SB can route the signal from this to this. Instead of this to this, it can route this to this, or it can route this to this. So from one CLB to output, how another CLBs will go, that depend upon the completely of our switching box. So it will is mainly, you can say, routing the signals between different CLBs main responsible, and CLBs will actually implement the logic function which is our desired. So if you go inside the CLB, you will find important thing that actually what present the CLB, a lookup table is there. That is already I have mentioned that what is the output will stored here, like indicator and marks. So that is our lookup table. The value, the function output I will store in the lookup table. Based on the marks and this output will come. If this is a combinational circuit, so marks configure bit will be always 0, because this should become immediately. We know in the configure combinational circuit, the input directly drives the output. So you can say also reverse way, the output fully depends upon the input. No storing concept is there. So there's time whatever the output is coming directly, you have to drive to the marks. That's why marks will be 0 every time it will be selected. But if it is sequential, that means I need to store, and the storage value you have to retrieve. That time configure bit will be 1. That should be remember what is the configuration bit in this case of CLBs. Is it clear? The marks configuration be directly be vendor 0 1, and LUT, that functionality whatever you have to generate, that you have to program in the LUTs. Just programming the LUTs, you will implement the different functionality. Is it clear? Suppose these are the your 4 input AND gate is a combinational circuit. So this is the your output of the 4 input gates. See, I have implemented all it is here. Just I have given my lookup table. I have stored the value for here. That means my task is that, but I have to configure the LUTs of the CLBs by the logic functions output. Am I clear this point or not? By the logic function output, I have to configure it. Let me program it. Directly I'll store. Is it clear? Or you can say in
Yes.
a naked truth, this is the thing that directly I have to, what is my required output, I have to place in my LUT. Is it clear? Clear or not clear? That's why
Yes.
I've written LUTs of CLB actually by the logic function of the output. It is configured It is configured by the logic function of the actual desired output. Remember, here it is 0. Can you tell me, Aditya, why it is 0? Aditya?
Sir, it is selecting, sir, the the inputs directly, like the blue line.
Yeah,
It
I
is
know blue
selecting.
line. Yeah, blue line. But why 0? Why I am targeting this one? Full concentration not happen in the class. Aniket Roy. Aniket Roy.
Yes, sir.
Why I have given that be 0?
Sir, don't know, sir.
Hmm?
Sir, don't know.
Orindam Paria.
Yes, sir.
Just
Hello.
what 1 minute. Srikant. Amgod Srikant.
Hello, sir. Can you hear me? Hello.
I am coming later on with them. You just wait. Amgod Srikant. From the last consecutive classes, I called your name and multiple time Srikant, I name iterated. This time I will not allow to appear in my exam. Just remember these things if you are unable to reply today. Amgod Srikant, are you there? You are fired from my class. Arindam Padia, tell me.
Sir.
Switch on your video.
Hello, sir.
Switch on your video. Is it possible? क्लास में हो या ऐसे सो के कर रहे हो तुम लोग?
नहीं sir.
तो एक वीडियो सिग्नल ऑन करने के लिए बोलता हूँ तो आप लोगों का दिमाग खराब हो जाता है. You should be always get ready with proper dress. I think there's the main issues. Okay, no issue.
Yes.
Now tell me why the marks be sir 0? बेटा मेरा क्लास करते हो 3 सेमेस्टर से ऑलरेडी झेल चुके हो तो you know what type of teacher I am. Either give full concentration, otherwise don't attend the classes. In the next classes, if I ask question unable to answer directly, I will fire from my classes. And that can continue for the next 1 week. Omuk Sai Sikant is suspended for 1 week from my classes. Abhishek, inform him this message.
Yes, sir.
The Bivas sir has told that next consecutive 2 classes you should not attend this week. क्लास में घुस जाता है, सापड़ी मिल जाता है, फिर भी अटेंडेंस क्लियर नहीं करता. निलय रॉय. निलय रॉय. निलय है या नहीं पहले रिप्लाई कर दो. वेरी गुड. आउट हो गया, ठीक है. उत्सव आए थे क्या? अभी देखो सब भाग रहा है आराम से. मैं अटेंडेंस फिर से लूंगा, सब भागने दो पहले. हाँ भागो भागो. योगेश कुमार झा.
Yes, sir, present, sir.
हाँ बोलो. Why it is 0?
Sir, I couldn't understand properly. I
Very
was
good.
drinking water.
Sharna Bhopal.
Yes, sir.
बोलो.
Sir, because we directly want to output the content in the lookup table and we do not want to store it.
Why?
By yes, sir.
Why? We don't know to understand why.
Uh,
ये क्या लिखा है?
Configuration. combinational circuit.
मतलब
In combinational circuit, where the output directly depends on the input, and there is
okay.
no concept of storing the.
That's why we are giving marks which has 0. That directly I will retrieve from here.
Yes, sir.
Clear or not? So this
Yes, sir.
thing I have explained. Now Aditya, clear? You told that blue line will be
Yes, sir.
selected. Why? Why is the answer is that? Because it's a combinational circuit. Sometimes something will be desired and then expectedly you have to do full concentration given the classes. So now you see here also same thing. Actually find the configuration bit for the following circuit. Tell me. So this is the circuit I have given. I have to find out the configuration bit.
Sir, one, sir, because it's sequential.
That means here I have to give 1. Very good. Okay. And what I have to given here? What I have to put in the LOTs?
The output, sir, like the
Tell me.
sir, in this case, boost one marks. Yes. Sir, 1. So like that.
Is it? What I have written it is correct.
Yes, sir.
Yes,
If s equal to 0, it will be selected. 1, it will be selected. 0, it will be selected. 1, it will be selected. 0, it will be selected. 1, it will be selected. 0, it will be selected.
স্যার এটা আরেকবার বোঝাবেন?
Based on the selection line from A0 A1 output will be selected here. So what output will come in the D as per the clock signal? D's output will directly go to the input will go to the output. So now first find out the D's input. Now when S equal to 0, it will select the A0. So A0 output 0, that's why I've written 0. When S equal to 1, it will select the A1, so A1 is 0. When S equal to 0, again it will select the 0, so that's why it is 0. When S equal to 1, it will select this page, that's why it is 1. When S equal to 0, it will select this one, so this will come 1. Again S equal to 1, so it will take 0, it will be 0. Again S equal to 0, this is the 1. So like in this way, it will come. And when our last bit is S equal to 1, it will be 1. So finally 1. So 0, 0, 0, 0, 1, 1, 0, 1, 1. This entire bit stream will be fed to LUTs. Now it is clear? Or I have to repeat? I can repeat 10 times, 12 times, 108 times. There will be no bound. But until or unless you don't understand, you can't tell me go forward. Is this clear? Or not clear? Or again I have to repeat.
Sir, please repeat, sir. I didn't get it, sir.
স্যার কনফিগারেশন বিটটা 1 হলো কেন একবার বলবেন?
আচ্ছা, okay. All of you have wake up from the sleepy mode, na? Thank you. At least asked question. Otherwise, in the exam, whenever I give the circuit, you don't know how it is coming. But once you understand this thing, I think no more study is required in the home. Are you getting my point or not? This is digital. You can understand from the class itself. I don't know what you are doing. Are you playing video games? Most favorable thing. Okay. Now see, it is a marks and marks outcome depend on the selection line. First, I am taking what is coming this position. Now, when s equal to 0, then s0 that means it will be propagated. So what is the output? 0. When s equal to 1, this will be propagated. So what will be the output that time? It will be again 0. Okay, Prajota, tell me Then what I will write here?
Sir, 0.
0.
Again.
Aditya, tell me what I will write here?
1, sir.
1. Any other fellow who don't understand, can you tell me the next bits? Anyone?
One.
Sir, 1.
One.
1.
One.
1. 1 because it is 0, it will select this one. Now it is 1, again it will be 0, then again it will be 0, it will be 1, then
One.
again 1, it will be 1. So it is clear?
Yes, sir.
This entire bit stream, that is my desired output here, and that is D flip-flop. That is what? D flip-flop. So D flip-flop, what we will do? By the presence of the clock, whatever the input, it will directly drive to the output. Is the data flip-flop register. So this will be my output in presence of clock. But be careful, final output I am getting from here. So lookup table will be configured with this one, that whatever we are getting here. So actually this is nothing but here no changes. So final output is nothing but this one in this case. So that's why in the lookup table I have written 0 0 0 1 1 0 1 1. Okay. So that's why I have written from this lookup table whatever the output is here. So I have written. Is it clear? Is it clear up to this?
Yes.
That
Yes,
means
sir.
my final output, whatever is coming from here, I have configured my LUTs. Now you see the output you are getting, they are not directly, you are getting from flip-flop, from the flip-flop, which is a storing unit. So that's why a marks we have to seek the D flip-flop output, not this one. The lookup tool directly I can't get. Via this I have to receive. That's why I have to say with the 1. Because if 0, this will be selected. If 1, this will be selected. So that's why it is 1. So what will be actually the configuration bit when I write in the CLB programming? So this will be the CLB programming, and last one is for marks. So this bit stream I will write in the CLB. And the automatically CLB last bit will go to the marks and rest will go for the LUTs, and as per the logic the circuit will work. Understood?
Yes,
Understood or
sir.
not?
Understood, sir.
Clear all of you?
Yes, sir.
बहुत आहिस्ता आया. Now the CLB I have configured, suppose with that bit, whatever bit stream I have given 0 0 0 1 1 0 1 1 and 1 for marks. That is the last bits for mark. I have configured. Now come to the switching box. What happened actually this switching box? If you notice, switching box can work two way. One is anti-fuse technology, another second is that STEM technology. That what I have shown, it is STEM technology. It means that whenever I will give 1, so the bit will be, this path will be sorted and the output from this 2 will go this way. If I sort it with the 1, the output will go like in this way. You can't give this both. If you give both 1, then this will go this way and this will go that way also. Both the way will propagate the output. Are you getting my point or not? So
Yes.
from one CLB to other CLB, maybe here the CLB, other CLB also, or maybe other switching box also, you can propagate based on the configuration. Its configuration style is that 0 0 0 1 0 0. So if I write the SB's configuration from here, if you notice the configuration bit for SBA, a standard procedure is followed here. So I can write first bit 0, then second bit 0, then this 0, then 1, then this be 0, then this be 0. Like in this way also you can write, or you can follow the standard whatever that configuration followed by the board, you have to write as per accordingly, you have to propagate. So you can program the SB also, and corresponding SB switching will work. That is the STEM technology. In anti-fuse, two wire are connected like in this way, like in this way. When you short it, then it will go like in this way. When you short this line, the bit will go like in this way. Actually, in fuse technology, when any applied voltage is fair, it is disconnected. You found fuse circuit is whenever over voltage happen, fuse circuit is broke the circuit. Here is the anti-fuse. When any voltage is applied, actually it is connect the two terminal. So that's why it is called anti-fuse techniques. Is it clear why it is called anti-fuse? Is it clear why it is called so
Yes,
antifuse?
Sir, could you re-explain, sir, the antifuse and SRM, sir?
I am telling that if the two terminal wires are there, if there is connections are there, when the voltage is applied, what happen in fuse technology, it is broken and you just separate the circuit. That is the fuse work. Every day in the house where the fuse is kept for the security of the circuit, whenever any voltage will be high voltage or high current will come, the fuse circuit broken itself to this separate this both the connection to safety the voltage overflow in the circuit. Am I correct or wrong? This is the fuse purpose of fuse. Clear?
Sir.
फ्यूज नहीं है क्या घर में, या तुम्हारा ब्रेन का फ्यूज उड़ गया?
Sir, brain का.
Ah, fuse circuit is there. Whenever any voltage is applied, the fuse circuit will break itself to isolate the both the circuit separately. Clear? So that is the concept of fuse. Antifuse, that one voltage will apply, if the connection is built up, then I can see the antifuse technology, and that is happen in case of SB. That's why it is called antifuse technology. What happened that they are mostly just joining each other by applying the voltages in the joint. As per your requirement, they will build up. But mostly we are using this STEM technology in the FPGA. So that is the ASB's connections we discussed. Now what happened that you find that in these cases you can say these are the different slices. So the slices can run parallel. Remember, slices, the you constitute the different slices with the parallel combination. The horizontally, if you column wise separate it, you can say these are slices. So one logic you can implement here, other logic you can implement here, and parallel you can run and configure, get the output from the single circuit. So that is the strong powerful approach or powerful application of the FPGA, that we can run all these things parallel. Is it clear at this point? Is it clear or not clear? How it is under those slices, number of slices particularly it will be given. You can understand how many slices are there and how many slices you can program as per your requirement. You will go. Now suppose we have to implement this circuit. You have to implement this circuit. So first of all thing, I have to implement one circuit at a time, one CLB. First I will implement this in one CLB1, and after that this second part I will implement into CLB2. Getting, you can get the output from CLB2 also, or you can get the output from CLB3 also as per your requirement. The inputs are given like in this way, and finally you can get the output from this corresponding circuit. Is it clear this approach? So based on the different input configuration, you can get the output. So finally you can get the output from here or get the output from here. Inputs also can be given or received in the both the way. So it is the entire CLBs are programmable. Now you just tell me in these cases, if you notice it properly, the what I will implement, I have to implement this function. So what will be this one? This is the AND gate. Can I say this is the AND gate? Then two input AND
Yes,
gate.
sir.
0 0 0 1 1 0 1 1. What is the output? 0 0 0 1. Clear? So that will be the LUT's input and marks input, because it will consist of sequential behavior. So marks will be 1. So 0 0 0 1 1. Can I say this is the my CLB1 configuration? Is this understood by you or not? I will configure this bit stream in this CLB by programming. Then automatically this function will perform. Is it clear?
Yes, sir.
Okay. Next is that we know the output of this one and this will be XOR, and XOR gate nothing but 0 0 1 1 0. Clear? XOR gate, any 2-bit combination, 0 0 you'll get 0 0 1, you'll get 1 1 0, it will get 1, and 1 it will get 0. So finally your requirement is that 0 1 1 0. Since it is directly getting, what will the configuration bit have?
0.
0. So this
0.
I will fed up into CLB2 and this I will fed up in CLB1. Is it clear? Now our main target there is SB programming. In the SB, you know directly I have to send the message. So SB, all surrounding these 4 bit will be 0 and this bit will be 1 and this bit will be 0. So I have to configure the SB this one. Is this clear or not clear?
Sir, explain the SPSB please. Sir.
नेक्स्ट पेज में कर दूं? ठीक.
SB sir. SB.
हाँ SB वाला देखो, SB तो ऐसा होता है ना, 0 0 0 0 नो कनेक्शन. मुझे तो ऊपर से नीचे जाना है ना.
Yes.
If you notice it, so I will give it is 1 and यहाँ पे बंद है 0. तो 0 0 0 0 इसके बाद A 1 और इसके बाद 0. तो ये SB तो हम वहाँ पे फीड अप कर देंगे यहाँ पे. सो यहाँ से सिग्नल यहाँ पे आ जाएंगे क्योंकि ये आउटपुट तो मुझे वहाँ पे जाना होगा ना. Is it clear? Finally from the CLB2 you can get the output. Is it clear this point? So see, initially this for this lookup table and here 1 because we are getting output from the sequential circuit. That's why this is the configuration bit 0 0 0 1 1 for CLB1. This is CLB1 and here will be 0 1 1 0 and final bit 0. That is for output for the directly CLB2. Is it clear? Now the placement selection. That means the CLB2 and CLB configuration finished. Now I have to go to the SB1. Now what should I do? See, I have to send the signal like in this way. That's why I fixed this bit only 1. So rest all bits is 0. So 0 0 0 0. So 4 0 and this bit 1 and this bit 0. Sometimes you have to counter this one first, so 0 and last bit you have to fix 1 if you last bit you configuring. So that is the configuration system of the particular hardware. It will be given in your manual. So as per that either it will be 1 0 or 0 1. Are you getting my point or not? Which bit comes first according to you have to set. Is it clear?
Yes.
Now if you again you have to pass CLB2 CLB3, you would like to get the output from the CLB3, then again you have to configure this one also because this is for your CLB1 first logic, it is second logic and finally you would like to get the output from this one. So that's why 0 0 0 0 1 0. So you will pass the message here. So 0 0 0 0 1 0. So it will pass from here. Now after coming here CLB3, problem is that in CLB3 there is no logic. Is there any logic left? Is there
No,
any
sir.
logic left?
No sir.
No logic because this is CLB1, CLB2. Now what should I do that directly I can get the output the CLB3? You know, in a AND gate, whatever if I fix this bit is a 1, whatever the input here, are you getting my point or not? What are the input here? It will directly give the input here. Am I correct or wrong?
Yes sir. Yes sir.
So whatever the output is coming from here, that is the CLB2's output. Whatever it is coming here, if I fix this with 1, the automatically input should be 1. So what will be the configuration? Again I am implementing a AND gate here. Again we are implementing AND gate here. Clear? Again I am implementing AND gate here. So what is the AND gate configuration? This is the AND gate configuration. Correct? And here output will 0 because it is a combinational circuit 0. So if I set this bit here and here is the again it is for AND gate because 2 bit AND bit was there, it is OR gate. Set this here. Here will be 0 0 0 0 0 1 to come here and here will be 0 0 0 0 1 0 to go there and in this cases 0 0 1 0 set here. So just setting these 4 configuration bit, other will not work, other can be used for other purposes, only this will work. Am I correct or wrong?
Yes sir.
You can configure this, you can get the output also. So parallel or multiple logic function can be implemented using the FPGA and that's why it has so much. Or you can get one thing that directly you can get output from CLB3, you can propagate here also. And finally from CLB3 you can get output. As per your program you can do. From here you have to send the message there. So what happened? 0, 0. Once you will come here, you are actually propagating this signal. So you are at this diagonal. So your first bit should be 1 and rest all bit should be 0. So signal will go this way instead of going this one. Am I getting? So just configuring the SB and CLB, you can get different multiple. So it is the best way. So can you guess the idea whatever I have given? What will be the CLB3 bit that time? Now you can guess it. CLB1 is this one. Means this is the AND gate. Since this bit is 1, so it is coming from the D flip-flop. So I can write the circuit like in this way. This is the marks actually, and the D flip-flop output. So it will be 0 0, and you are getting marks bit is 1 because from sequential. So nothing but actually, if you say the lookup table here like in this way from the lookup table marks, so you are getting this CLB. This CLB nothing but a AND logic. Am I correct? Am I correct or wrong?
Yes, sir.
And this
Yes,
is
sir.
nothing but the XOR logic. Is it clear?
Yes, sir.
So you are implementing the circuit like in this way. Three input, and actually you are getting the circuit from using CLB to CLB1 and CLB0. Here I have written CLB is don't care because I don't bother about this output of the circuit. It can be anything. So that's why I get don't care. But what will the CLB3? If I need to get the CLB3, I have shown it should be directly a AND gate. So that's why it should be right like in this way. Can I write this configuration here? Because
Yes,
in the
sir.
AND gate, you know if the circuit bit is 1, whatever is the other output that will go there. If it is 0, it will go 0. If it is 1, it will go 1. Actually, what is the output of this one? Directly it will be driven. So that's why I implement the AND logic, and the bit 0 is for directly to receive the combinational output. Now SB 0 all 0, so it will not go directly output. Now SB1 0 0 0 1 0, so it will go like in this way. That's why if you notice, I am not using SB0 because all are 0. So I am using SBA, so it will go directly in this way. That's why you check it. I have given 0 0 0 0 1 0. That means if you say the circuit like in this way 0 0 0 0, and after that there is a 1 and then last bit 0. So 0 0 0 1 0. Is it clear? So now it is coming straight. Then SB2 again 0. So there is no purpose of SB2. I am not using this also. Then CLB2 logic. Then SB4. Then what is the SB4 combination? You can check SB4. SB3 also all 0 because we are not using it. So here also large bit 1. That means I am using this connection. So it will go to the CLB3. So like in this way, just changing the configuration bit as per your desired goal, you can configure. Once this configuration is performed, it is looks like a SIC because this is performed for this circuit. Now it will work. Are you getting my point or not? So that configuration part, once it is built up, then use purpose circuit. Again you change the configuration bit. Again you change all these things. The same circuit will behave separately. Are you getting my point or not? So every time you does not need any separate new circuits or new chip is not required for fabrication because same chip can be used for multiple purpose. So that is the flavor, or you can say the USP of FPGA. That's why FPGAs are now mostly popular in the digital arena. Okay, is it clear? So it's a realistic FPGA of the CLB of any Xilinx. The whatever I have given, it has a multiple combination lookup tables are connected to each other. Are you getting my point? Multiple lookup table was connected with the different marks, and now the B stream also I can configure and give. So this is the complex view of the lookup table. Again, same thing. You have to just configure and change. The routing will take place by the CLB. Routing is always done by the SB, and CLB will the configuration, and the CLB's part is directly by this one. So actually what happened there, you know, a CLB nothing but a lookup table, and lookup table will be connected to the D flip-flop or with the marks. So this is the actual CLB, a lookup table, a D flip table, a marks. So what happened in the CLBs, you see multiplexers are there, D flip-flop like activities are there. This is also marks, and this is the lookup table. Is it clear? Finally, you know SRs are there. What is SR? What is SR? Even now,
Flip flop, sir.
flip flops are there. This is a D flip flop. This is a D flip flop. That is clear. That is the electronic configuration. For time being, you will not understand. For short circuit, or you can say they want to clear the state. All these things we will use it. For time being, you just remember that what are the basic component? Flip flop. That is D flip flops are there. Multiplexer marks are there, and lookup table LUTs are there. So basic combinations are these, whatever I have this time. So this actually happen in the one CLBs are present in a marks. So what is we conclude from this lecture? Must provide a design environment based on digital design concept, gauge flip-flop mask, etc. Must hide the complexity of placement, routing and bitstream generation from the user. Manual placement, routing, bitstream generation is infeasible for practical FPGA. आपने जो कॉन्फ़िगर किया ऐसे ही काम करेंगे ऐसा नहीं है कि you placed like in this way, but sometimes it happen that circuit configure as per your requirement separately. You are using some SBA, but they can use another SB. But the configuration output you will get. So little bit changes are there inside the real world, but the actual concept is almost 100% same. Okay. So that's up to the today's class. Any doubts? Any doubts from FPGA? So one thing now you can start. Just 1 minute. My screen is visible.
Yes, sir.
Icaras Verilog. Icaras Verilogs are there. Icaras Verilog tutorials also there. You can download, and this also for Mac version also there. So Icaras Verilog tutorials are there. You can go for Icaras Verilog. Is an open source system, and here the whatever the configuration bitstream, how to write all these things, and initially you study the Verilog. Okay, you will find how to install Verilog, testing Verilog, and you are using Verilog Windows simulating to input and gate or gate. All these things are given here. Okay, so you can start learning the Verilog fast. So many help files there. Main my target is that you have to study the Icaras Verilog. Okay. Though your teacher will give some idea later in the laboratory, but in the very beginning in the hour, you go for Icaras Verilog. Okay. Icaras Verilog is clear to you?
Yes, sir.
So is a hardware definition language HDL. You can try to learn from this web source. Okay, you can download all these things are available here. A Verilog you can download also. Okay, you can download for Mac. Online also you can do all these things are there. Okay, how to compile some tutorials points also given some online Icaras Verilog download compilation also. So student, next class you should get ready with Icaras installed in your system. Is it clear?
Sir, this FGPA chapter in which book can we find properly?
FPGA. Not understood my lecture?
Yes, what you taught today, FPGA. In which
there.
in which book can we find it
Right,
properly?
there is no suitable books. Actually, that I have followed the constant side, but even PGA book, any PDFs are there or not. I have to check it. Any book you can follow, but let me see one good books for this one.